How you guys doing today? It's the last lecture, right? So we're almost done. So from the last week, we've been doing a review. So I'm gonna hold another review today. Here's the first one. Try the. Let's try this real quick. Acid halide with water. Okay, about 1 minute, we'll do this together. All right, so here's the thing. As you can see, this is not very strong nucleophile, but still this carbon is really electrophilic because the halogen group and the carbonyl group over here. So when water goes there, and will be deprotonated by the base. So it will be this one. So it will be not water, but hydroxy group. So in whole, it's a carboxylic compound. But this will pair with the proton here. So it'll be HCl when it leaves over here. Okay? So that's it. Okay, so the trick will be this one. So whenever you have an acid halide, which is very electron poor carbon there, just replace them as those. That's the trick. All right, so let's do another one. Maybe you have acidic chloride, and then plus acetate-amine. What might be that will be? Okay, 1 or 2 minutes. Okay, about 30 seconds. Okay, so here's one thing you can do. Whenever you look at this carboxylate and also acid halide compound, one trick you can do is you can just flip this one. Okay, flip this one over here. And then you look at this one, it's very electron rich, will attack the electron poor region over there. And it goes to up and down and goes back. Okay? So what happens is literally you just remove that one and it back to original carbonyl group 1 here, but this will just to this one. Cl minus will just leave. So that's pretty much. Okay. All right, looks good. Then the next one, let's try this one. Plus 2 ammonia. 2 ammonia. Not 1, 2. About 1 more. Okay, so here's the thing. So this one, the lone pair on nitrogen goes to here, electron per carbon, and down here. So will become actually initially this one, but another ammonia grabs the one of the hydrogen, so become amine groups there. So this is gone, and then this will become ammonium cation paired with that left chlorine anion. It's become salt. Okay. So this is your amine. Okay, good. Perfect. All right, that's a little bit of a tricky one. Just not so tricky. This one. We have an ester group, ester compounds with two, so there will be two Grignard reactions, and it will be conditioned at the acidic conditions. Okay, so for this one, this is your leaving groups. Okay, this is your leaving groups. Whenever you have the R group added on here, okay, so when it does, on here, you just need to have this one to leave. Okay, so this will leave as anion, and then when you have this one, but there's two, so we're adding two methyl group, and will be protonated by the acidic condition. So it looks like this. So the thing is, you have an R groups on here, Grignard, add a 2 over here, and then you have the oxygen in the carbonyl group will be protonated by the acidic conditions, and this will become also ethanol at the acidic condition. Okay? So this is your table. Okay? So you can redraw this one like that's okay, because it's a single bond you can rotate. But either way, it's actually fine by me. Okay? So the thing is, whenever you have the ether group like in the ester, it will leave as like acidic form, which is alcohol, and that the carbonic group, the oxygen, will be protonated as become like hydroxy group. Okay? So that's it. Makes sense, right? Okay. Bit tricky. All right, let me try. This is also a bit tricky. Okay, so the trick here is actually pretty simple. You only need to do this one. That's it. So what actually happened is the hydride will from here and here, but instead of them leaving this one, because the amino group is very poor leaving group, instead of leaving this one, they leave the oxygen away. So that is why we'll be just removing carbonyl groups, leaving this amine groups. All right. do. So it's a similar one, okay? But if you can try this one, it's a very similar one. Okay? It's similar, but you have just different components right there. Very similar. Okay, so this one is almost the same. You just need to do this one, but the difference is this is actually the one over here. So you didn't have that on the lead, but the trick is you have the carbonyl group oxygen will be later protonated by the condition. So we can do the same trick here, but just slightly different, but product-wise, let's move on. Okay. Oh, we're almost done. Okay, do you guys actually remember this one? Nitrobenzene. We're going to trip with some H2 with the catalyst. What happens? It's nitrobenzene trip with the hydrogens with some catalyst. What happens? Okay. The simple change H2 will be reducing something. Won't be on the carbon in the aromatic ring because it's very stabilized, but nitrogen, right? So, okay. So what you can do is what? You're gonna do NH2. Okay, so this is the part. All right, let's do a little bit of a trick here. With ammonia or sodium chlorhydride. This one. Okay. Yeah, maybe 10 seconds. Okay, so here the trick is you just need to have amine groups there, and later. Okay, so that's it. You just need to replace the one with the carbon and carbonyl groups, the amino groups and hydrogen. So it looks like this. Amino compound. So ketone will become amino compounds. All right. So let's do one more. You can try this one. The amine group. Sodium hydroxide, bromine, water. So this is the, I think this will be 100% on final exam. This is what we call Hofmann rearrangement. You just need to remove everything. Just there. So the carbonic group on the whole with the carbon all gone. So they rearrange to the nitrogen instead of carbon. They read as a carbon dioxide. Okay. All right. So